Okay, it's a pleasure to give an update on the activities around field level, so bringing OPC UA to the field level. And just quickly, you see there are two terms we're using, FLC, FX. Probably you're all aware about that. FLC is the term when we talk about the organization or the initiative inside OPC Foundation. And FX is the term for the extensions we do to the OPC UA framework to cover the needs of the field level. So I'm not going into any technical details. So my plan is to give you an overview, what is going on, certainly mentioning some of the challenges and also what has been achieved, and also looking a little bit in the future, what is actually coming up. And what challenges we still have in the future. So bringing OPC UA to the field level means we need to cover a lot of requirements that have so far not been solved by the OPC UA framework, just because it was not used in the field area. So you see some of these requirements in this yellow bubble. We have to support functional safety, we have to support deterministic transport. And then we have a lot of different application areas like motion control, remote IOs, instrumentation. So you see there are a lot of different aspects we have to consider. Because of this complexity, the initiative, which consists in the steering committee of 25 companies, has decided at an early time to separate the work in two steps. First step is doing the controller-to-controller connectivity, so the horizontal connectivity between controllers, and then extend to all the field devices, which is what we name controller-to-device, also including the direct device-to-device communication. So the overall approach is, as I said, to extend the framework of OPC UA, not to create a new ecosystem. This is why we're building, and you see this in the dark blue boxes, we're building upon existing OPC UA with client server, with pub/sub, the built-in security, and very important, the information modeling capabilities, because we need to create information models for all the different types of devices you find in the field. And these extensions are here highlighted in the orange color. So we develop base models for any kind of automation components. This is the general term for all the different types. But then on top, you see the specific models that we need to generate for all the different types of devices. And you see some mentioned here, motion, instrumentation, I/O. But you see also the ... So there might be additional specific models or facets that we generate in future. And very important is what you see above. We certainly can combine these core models we develop with any kind of existing or future companion models. For example, those that are developed by the VDMA, but also from all the other organizations we are cooperating with worldwide. And the vendor-specific models can be, so to say, on top. Now going to the lower parts, certainly we have so many different requirements because we want to fulfill the needs of process automation as well as factory automation, that we need to do a specific mapping or binding to underlying protocols and physical layers, depending on the specific use case. I'm going into more details later when it comes to really, does this go over wired connectivity, Ethernet? Is it with deterministic Ethernet? Is it maybe even wireless? So we have many different options there. I explain a little bit our approach to be flexible enough to cover all the different needs, the complete range of requirements. Now I heard in the presentation before the term, not reinvent the wheel. This is something we very often, let's say, state, because it's extremely important that we consider what is already existing, that we can use and reuse, and what are things we have to create by ourselves or jointly with other groups. I like this slide because it shows you all the different corporations and liaisons we have in order to combine things to finally make, let's say, a comprehensive and usable profile for the different devices and the different scenarios. So just to give you a rough overview, whenever it comes to communication, we rely on existing standards out of IT. So we're not creating any specific solution with a specific hardware controller. So this is why we rely on Ethernet. We rely on the new type of Ethernet, Ethernet time-sensitive networking, the deterministic Ethernet, but also have liaisons with, for example, the 5G ASIA to make sure we easily can integrate 5G into our concepts. And from the 5G ASIA side, also the other way around, how does OPC UA fit into the 5G ecosystem? So this is more about the communication. If we look at the higher layers, it's clear we create something for field level, and this is where we have the many field bus organizations active since 10, 20, 25 years. And also here we do cooperate because we say we need not reinvent things. We want to reuse proven existing device profiles, for example, and you see here 4 field bus organizations listed that we established corporations with, its safety, its motion, and its instrumentation. And we have also cooperation with Automation ML when it comes to offline engineering. Here I have some further information a little later. All right, so this is more explaining the overall approach. I'm going in some technical things a little after reporting on the status. But important is we have working on these concepts for 5 years now, and you will certainly ask, what is the progress, what is the status? So I would state today we are close to the finishing line with regard to all the specifications we need for this controller-to-controller use case. I mean, I stated very early we might take only 2 years, but that was for sure a little naive because we have all these big players working together, and the 2 years were really optimistic at the very early time. And now I think we can really be happy that after 4, respectively 5 years, we have a common agreement. And you see now here the specification series consisting of 5 parts. They are numbered 80 to 84. We had a first release out 1 year ago, and since then working on some revisions and also finalizing one part for the offline engineering where we did not have enough prototyping at that time. So now what is currently under member review is revisions of parts 81, 82, 84, the new part 83 for offline engineering, and we did not change the overall introductional part 80, because all the concepts are stable and proven. All right, so maybe a few words about the new part, which is coming up, part 83. The plan is to release it in January after going through member review. And this is an important concept because it is not sufficient for field level just to deploy real devices in the field, but you need to exchange at an earlier time when you do the engineering, you need some preliminary information, typically called device descriptions. We call it the offline descriptor, which contains all the capabilities, the features, or also constraints of a controller in the first step, but then later also for all the field devices. And this descriptor is being exchanged between stakeholders to actually plan a project without the real devices, but then at the time of commissioning, you deploy a certain configuration to make then the real operational, let's say, application. Now, we rely here on the Open Packaging Convention, which is a possibility to combine different files into something like a zip file. We can secure this with a digital signature. And the information model that is included in this descriptor is based on automation ML, which is the common standard for engineering that we also share with other associations that adopt OPC UA. And certainly, this concept also allows us to integrate other types of files that we, for example, need for network configuration, the young models. We can also link to certificates that are needed to provide security. So this is a very flexible and powerful concept. A few words about safety. Safety specification has been out for quite a while already. Started out of a cooperation with Profibus Profinet back in 2018. You see, we have a stable situation because we already had 3 releases out. So the last one was 1 year ago, which is having, let's say, support for client server as well as pub sub. So this is all we need for also adopting safety in UAFX. We have a certain delay with regard to the 2 projects that I reported already last year, but it's safety, and it's not surprising. Safety sometimes takes a little longer than you would expect. But also here, I would say we are going to the finishing line. So for first quarter next year, we can expect that for the 2 projects we have ongoing, one is the safety test tool, and the other one is a safety stack that can be used by the different companies. We hope to have the TUV assessment and certification, and then companies can use it and can reference this pre-certified stack and use it in their products. All right, now as we are going towards the finishing line, I created this one slide to explain a little bit about the key achievements so far. So this is, so to say, a summary of what I would see as a big success of the initiative. So the first topic is the harmonized communication solution that we have created, supporting factory as well as process automation. Using the pub sub for supporting cyclic, real-time, and also safety-critical data exchange. And also from the concept that not we develop, but it's part of OPC UA framework, we can go over wired, but also wireless communication. So I think this is elementary because this is also the foundation for the other use cases we are now dealing with in future, controller to device and device to device. Then maybe another great success is that all the companies, and you see here the 25 companies part of the steering committee, they were able to agree on exactly one controller profile. So I was expecting they have different viewpoints, and to make a compromise, we might have 2, 3, 4 different ones. But I think it's really a big success. They agreed on exactly one, what makes it much easier to enable this interoperability across vendors. So we have comparable features that fit to each other. Important, and I go into this a little bit more in my next slides, is the scalable network concept. In order to fit to the different requirements we have with regard to performance, with regard to efficiency in the transport. So I'm not explaining this now, but in the next 2, 3 slides. The safety solution I already mentioned, as well as the offline engineering. And finally, I come to this also in a separate slide. We prepare conformance testing, which is elementary because we do critical devices in the production in factories and plants. So conformance testing is, let's say, essential for ensuring the high quality and the robustness of the solutions. Now, with regard to transport, I think this slide is helpful to explain a little bit how we are able to meet the different needs. So first of all, on the left-hand side, you see with number 1, the TCP/IP that is used by client server. Because TCP/IP has a large overhead and it's not, let's say, real-time capable, we only use in FX the client server to initially set up connections that are then using PubSub. So this is just for the initialization or for the, let's say, preparation phase. After that, we switch over to PubSub communication, which is much more efficient, more flexible. And here we have to distinguish two different types. We have on the one hand side the PubSub over UDP, which is, let's say, a routable protocol, but it's not extremely efficient. So this is here the number 2. But then if we go to higher performance, maximum efficiency, we are directly going from the PubSub UADP into Ethernet layer 2. So we're directly inserting the data in the Ethernet frames. This is also understood as the raw Ethernet. So 3 is, so to say, the use case, high performance, motion control, high-speed IOs. And 2 is more the approach where you can fulfill the needs in, let's say, low-performance applications or process industry. And from that, you can see we are flexible. If you look at the lowest layer, you still see here Ethernet mentioned, but also including TSN. And this is another aspect because we certainly have also at the layer 2 options. We can go with conventional Ethernet as we have it today, broadly accepted and used, but we also can go with the, let's say, new version of Ethernet supporting deterministic transport. And this is what I show you in the next slide. Again, we came to a compromise and a solution which allows us to scale depending on the specific needs of an application or use case. So you see here with the dark blue color, the mandatory elements in our networking facet approach. This is, as I said, going with UDP, and here it's named the base network access facet. You go then over the, let's say, transport, for example, Ethernet. Everything else you see here in the light blue is an optional feature because this is then scaling up the performance or scaling up the capabilities in the quality of service. So first of all, optional is in the end devices to have a bridge because not all the end stations or controllers need to have the bridge included. But those that have the bridge included, they then have to at least support the so-called base bridge, which is supporting VLANs and the remote management. So this is mandatory for all the bridges, either integrated in end stations or even external network infrastructure components. And then we scale further. We have the advanced bridge component facet, which is adding preemption, which is a way to interrupt the long frames in order to bring through the high priority traffic in a faster way. And this is also adding the time synchronization. So this is already related to TSN, its advanced capabilities. And then finally, we have the, so to say, full-blown TSN. And this is then adding the scheduled traffic where you reserve certain, I would say, time slots for your critical traffic. This is understood as the QBV or time-aware shaping, TAS. With this concept, and this is a term very important to us, we support this so-called graceful degradation. So assume you need high performance. You want to activate also these advanced features or even the full-blown features. Then it's required that on the path between the in stations, all the bridges support certainly these kind of features. If you have, let's say, a bridge only supporting the base features, you certainly lose a certain quality of service. And then you do the graceful degradation. That means you still have interoperability, but your performance is less. I'm running overtime now. OK. So this is, I think, another important aspect when looking at FX. This is how we scale and meet the different requirements. Okay, a few words about certification. As I told you, certification is a mandatory element because critical devices in critical operation. So we plan to have in the first quarter next year a quite robust certification tool based on the CTT. At the same time, we hope to have the safety compliance tool ready. So then prototypes can be, let's say, tested against our reference and hopefully then certified soon. We have different corporations whenever it comes to using joint technologies like TSN and also the Ethernet Advanced Physical Layer, where we cooperate with other organizations. A few words about the live demonstrations or multi-vendor demos that we have been doing. You see here a wall that we now have done 3 times, and we show this on the different trade shows all around the world. So one for Europe, one for North America, and one for Asia. It shows the controller-to-controller use case with overall 16 controllers from different vendors. This is seen on the left-hand side. And then on the right-hand side, we show safety demonstration as well as an interesting use case combining all the elements, safety, controller-to-controller with FX, and 5G. Stefan already showed you the demonstrator we had for the first time at SBS show with Ethernet APL. This is more a look forward because it's more related to the field devices, which comes up in the next project phase. But this is an extremely important element because it brings Ethernet and OPC UA into the critical areas in the plants in process industry applications. Okay, then just spending maybe 2 minutes on the next phase. Because as I said, we are going to the finishing line with regard to controller. What is now happening? So we decided to launch the so-called second phase of FLC, beginning of next year, and the plan is to do this for a duration of 4 years. We are reusing the existing concepts out of the phase 1, so we're not now starting from scratch, because a lot of the concepts have already been done in a way that we meet also the C2D and D2D in the next step. So we focus in the following now on things like parameterization, we improve diagnosis and networking, and we also certainly further develop and then finalize the specific application profiles, motion I/O instrumentation. Important is the group is open for all the OPC Foundation members. Those that want to contribute to the steering committee have to contribute with financial resources as well as with manpower. So this is the precondition. But nevertheless, all the technical work is just open to all the OPC Foundation members according to the existing rules. The working group structure is in place. The one group that was still open, but you see here the new. This is an announcement we did just, I think, 1 or 2 weeks ago. This is a new group we established, the I/O working group. In case of interest, the kickoff is Monday in a week. We have already more than 30 companies registered for this event, so this seems to be a very relevant and big supported working group. And with that, I just show you the overall picture. What is the plan? Going from existing solution, OPC northbound, field buses southbound, with first OPC UA as second channel for monitoring diagnosis. We go with the first step C2C now horizontally using OPC UA for control. And the next project phase, bringing the concepts down to the field devices. And then we have a fully, let's say, scalable solution vertically as well as horizontally. One slide about further information, recordings, brochures, also the specifications. And with that, I hurried up a little bit, and thank you for your attention.